Want to be a topper in MBA entrance exams? Join BYJU'S Exam Prep, CAT and MBA YouTube channel and watch serial 99 percentilers teaching you the tips and tricks.
Hi guys, a very good afternoon to one and all. Once again, welcome to MAHCET CET preparation sessions from BYJU'S Exam Prep. So friends, in today's session, I'm going to take up a topic called clocks and calendars. This is one topic which is quite tricky. The tricks are quite, the rules are quite simple, but the trick or the trap is always in the way you calculate it. So it's basically a calculation kind of a question or a topic. The rules are very simple. We're going to take a look at the rules for clocks as well as for calendars. But I have seen numerous students making mistakes in solving the questions despite knowing all the rules. The application of the rule itself is done wrongly. So that's the problem with this topic. So let's take a look at what is this topic, why are there so many errors done by students, and how can we navigate this topic without making these errors. So we're going to start off with the topic called clocks and calendars. Now, as far as your MAHCET is concerned, on an average, you can expect questions every alternate year. So which means if you look at 2 years consecutively, definitely in one of the papers, you will find questions from clocks and calendars. So in terms of importance, I would say this is moderately important. I will not say it is very important or it is less important. I would say it is moderate in terms of importance level, simply because there is a 50% chance you will get it, there is a 50% chance you will not get it. That's the basic idea, right? So let's go ahead and take a look at the basic idea about clocks, and we will take a basic look at calendars and then solve few questions. A very good afternoon to you too, Karan, Rishabh and Krishna. Okay, so what happens in a clock? What type of questions come in a clock? When you're talking about questions from a clock, typically the questions are of 2 or 3 types. First type is angle between hands. This is the first type of question. Anything to do with angle between the hands, when do the hands meet, anything to do with the minutes and hours hand. Second question deals with, or second type of question deals with a clock gaining or losing time. Now what does this mean, gaining or losing time? So a clock can be set faster or slower depending than compared to the normal actual time. So if I say a clock shows 5 minutes or gains 5 minutes in every 1 hour, it means if I set it correctly at 12 noon, at 1 o'clock correct time, the clock shows 1:05. Gaining means it is running fast. Losing means it is running slow. So if I say a clock is running 2 minutes slow per hour, it means if this 12 o'clock is the correct time it has been set, then at 1 o'clock correct time it will show 12:58 because it is 2 minutes slow. So questions based on slow and fast, that is gaining and losing time, that's the second model of questions. Then the third model of questions that you can come across in your clocks basically kind of topic is mirror image. So what is this mirror image? This is actually very easy. Mirror image questions should be dead easy for you. The question basically says if the actual time is, let's say, 9:20, what is the time shown by a clock that is seen in the mirror? So what is the mirror image time that is being read? So the logic here is very simple for mirror image. The logic is, in fact, there's only one point of logic, and the logic for mirror image is always mirror image plus actual time should be equal to 12 hours. It should always add up to 12 hours. Simple logic. So if I say one image, whether it's actual or image doesn't matter. One of the time is 9:20, then the other should be how much? So 12 minus 9:20. How much is it? 240. Right? So if one, whether the actual time is 9:20 or the mirror image is 9:20, I really don't care. One of them is X, the other should be 12 minus X because the total should add up to 12. That's the simple logic for your mirror image. So these are the basic variety of questions that you come under this topic called as clocks. Similarly, we have questions based on calendars. So we will take up calendars too, but first let's try to take a look at questions based on clocks. Now before we get into this, as I said, there are three types of questions. Third model I already explained, very simple. I'm sure you guys know the first and second model also. However, let me give you a little bit of theory about the first model. The first model basically talks about the angle between the hands. Here, what you need to understand is speed of minute's hand. It covers 6 degrees per minute. Because remember, the minute's hand completes one full circle in 60 minutes, which means it is 360 degrees in 60 minutes, which is 6 degrees per minute. That is the speed of the minute's hand. Speed of hour's hand. This is half a degree per minute. These are standard values you should remember. So speed of hour's hand. So hour's hand goes only 30 degrees in 1 hour. Remember, it goes from 12 o'clock to 1 o'clock. So this is 12 and this is 1. So this angle is 30 degrees. All of you know this because the clock is divided into 12 equal parts. So each part is 30 degrees. So an hour's hand moves 30 degrees in 1 hour. So that is 30 degrees by 60 minutes. That is half a degree per minute. So these are standard values that you should remember. So what are these? So standard value is speed of minute's hand, speed of hour's hand, angle between any two consecutive hours, 12 to 1, 1 to 2, 2 to 3, it's always 30 degrees. So if I say what is the angle from 1 to 4? So 1 to 4 is, 1 is here, 4 is here. So how many numbers are in between? 2 and 3. So basically you have 30, another 30, 60 and another 30, 90. So from 1 to 4 exactly if you match or if you count, it will be 90 degrees. Right? But if I ask you a question which says, okay, the time right now is 4:15. What is the angle? The time right now is 4:15. What is the angle? So basically what happens at 4:15? Your hour's hand, this is your 3, this is your 4, this is your 5 and this is your 6. Now at exactly 4 o'clock, your hour's hand and minute's hand were like this. Exactly 4 o'clock. The angle between them would have been 4 into 30, which is 120 degrees. It would have been 120 degrees perfectly. Now at 4:15, what happens? At 4:15, if I change this color a little bit, then my minute's hand is exactly at this 3. My minute's hand is at 3. However, my hour's hand has moved a little bit away from 4 because for 15 minutes it has traveled. So what is this angle? That is what they're going to ask you. What is this angle? So effectively what you're saying is the 120 degrees is getting reduced. So you can use the relative speed of the hands. So the minute's hand goes at a speed of 6 per minute and hour's hand is going at a rate of half a degree per minute, and both of them, if you notice, are traveling the same direction. So the relative speed becomes 5.5 degrees. So that is 5.5 degree per minute. Now 120 is a distance between them. It's like your police and thief problem. So imagine the thief is the hour's hand and the police is the minute's hand behind. The distance between them is 120 degrees. The relative speed is 5.5 degree per minute. In 15 minutes, what will happen? So for 15 minutes, what basically happens? The distance will reduce by 5.5 into 15. So 5.5 into 15 degrees. This will be the reduction. So this is 11 by 2 into 15. So 15 11s are 165 by 2. So 82.5 degrees will reduce from 120. So starting distance is 120, 82.5 is reduced. So what is the remaining? 120 minus 82.5, and that will be your answer. So you can calculate all these angles by understanding what exactly is happening here. Okay, so we're going to take up questions like this. This is just an example. I hope you guys have a refresher reminding you about these kind of questions. So I'm not going to get too much into theory. The assumption is that you already know the basics. I just refresh some part of your memory. Let's dive directly into the first question over here. This is a question. Try to give me the answer in 45 seconds. Your time starts now. It's exact replica of what I just did. Alright, lot of correct answers but few errors too. The correct answer happens to be option B, 10 degrees. So let us see what is happening here. The angle between minute and hour's hand when the time is 4:20. Now as I said, you can solve these questions in many ways. I have solved the previous question taking 4 o'clock as my reference. Here I will take 4:20 as my reference and see what happens. See, I'm doing this in a different method so that you guys get to understand different approaches. So here at 4:20, so let us say 4:20, so this is 3 o'clock, this is 3, this is 4, this is 5 and this is 6. Now at 4:20 my minute hand should exactly point here. My minute hand should exactly point here and my hour's hand should have been slightly away. Okay, that is a bit more than needed. So this is how it should be. The hour's hand will be somewhat like this. Now the question is, how much is this angle? Now remember, what I will do here, or the idea here is, I will take at 4 o'clock and I will not make, initially when I, so what I want to say is, initially, this is my 3, this is my 4, this is my 5 and this is my 6. My hour's hand would have been here. This is where my minute's hand is. Now what happened here? Slowly the minute's hand came here. While the minute's hand was moving, the hour's hand moved a little bit. Obviously it will not move as much as the minute's hand, it will move a little bit. And basically the minute's hand is in exactly the same place where the hour's hand was earlier. Now the hour's hand is at this point. So if I want to look at the angle here, I can always start with the difference between them is 120 degrees. Then for 20 minutes they are both traveling. So 120 minus 20 minutes into 5.5, that is 11/2. So this is 2 tens are, so this is 120 minus 110, which is 10 degrees. So what did I do here? This is one method, which is the starting approach I showed you at the beginning. So starting reference is 120 degrees. From that my distance is decreasing. How much distance is decreasing? 20 minutes at a speed of 11.5 per minute. So that is 110 degrees decreased. So from 120, if I decrease 110 degrees, my remaining is 10 degrees. So that is one approach. We already know this. We saw this. There is a different approach. What I will do here is, I will say, look, this is the final position of my minute's hand, which is exactly at 4. So I now need to look at what is this angle moved. So this angle moved is nothing but the distance covered by the hour's hand, the distance covered by the hour's hand in 20 minutes, because the hour's hand initially was here. If you notice, this was my hour's hand. Now this is the hour's hand. So basically from here to here, the hour's hand moved in 20 minutes. So how much has the hour's hand moved in 20 minutes? That will be my answer, that's all, because my minute's hand is at the place where my hour's hand was earlier. So effectively the difference between them is nothing but how much the hour's hand has moved. So speed of hour's hand is half a degree per minute. Like this for 20 minutes should give you straight away the angle as 10 degrees. So this is one approach, nothing wrong with it. This is another approach, nothing wrong with it. We can do calculations on clocks in multiple ways. Whichever you are comfortable, please stick to that. Right? Let's take another question. Yes, Karthik, thank you for asking. I am doing well. I'm in front of you taking this class, so I'm definitely doing wonderful. Thanks for asking. Okay, next question over here. Once again, do this in 45 seconds. Your time starts now. Okay, so that's 45 seconds. Rishabh, Chinta, Chintabindu, Sanskar, Deshmukh, Alka and Anuj. Very good, that is the correct answer. It happens to be option A. So let's take a look at why is it option A. So the question says find the angle between the minutes hand and the hours hand of the clock. So we have minutes hand and hours hand, and at the time is 8:35. So this is my 6, 7, 8 and 9. Okay, this isn't perfect, so this, well, I'm not an artist, so my drawings are not perfect, so I hope you guys excuse me on that. 7 and this is 8. So at 8:35, so at exactly 8 o'clock, so I'll draw in red my previous position of the hours hand. This is my previous position. Okay, now the current position, I'll draw it in a different color. This will be here. And because it is 35, we know exact position of the minutes hand. 35 means the minutes hand will be here. Now, I know what is this degree. Because pointing at exactly 8, pointing at 8 and pointing at 7, this degree is 30 degrees. But I want to add this extra. So what is moving this extra? Only the hours hand is moving. Why is it moving this extra? Because it is basically the angle that is getting extra for traveling 35 minutes. At 8 o'clock, it would have been in this red position. Exactly. At 8:35, it is in this position now. So 35 minutes it is traveling extra. What is that angle? Speed of hours hand is half into 15. So this is 7.5. It is 7.5. Is it 15? Sorry, 35, right? 35 by 2, my bad. It is 17.5. Okay, 35 by 2 is 17.5. So now the answer is 30 degrees plus this 17.5 should be my answer, which is 47.5 degrees. So again, I did this without starting from the beginning at 8 o'clock. I just took, okay, 8 o'clock is my hours hand. It is going forward a little and my minutes hand is exactly here. So that is so if you notice, I'm looking at the first angle between minutes and hours, which is known to me at 8. Then I'm moving only the hours hand. So that is basically how I'm breaking down the question. So use this approach, your calculations become faster and easier. Let's take one more question. Now this time we're talking about gaining and losing speed. So it is fast running and slow running clock. Take this in and do this in 60 seconds. Your time starts now. Okay, so that's your 60 seconds. So what is happening here? A clock is set right at 12 p.m. So 12 p.m. in the noon, it is set correctly. It gains 3 minutes in 1 hour, which means if the clock shows 63 minutes, then the correct time is 60 minutes. Right? Because in 60 minutes, the clock will get 3 extra. So the clock will show 63 minutes. While there is no 63, it will show 1 hour, 3 minutes. That is 63, right? Whereas the actual time would have been only 1 hour. So for every 63 minutes it is showing, the actual passing is 60 only. So this is how you need to calculate for this kind of a question. Now the clock is showing 10:30. So from 12 p.m. to 10:30 p.m. how many on same day? How many hours is it? So 12 noon to 10:30 p.m. it is 10.5 hours. 10.5 hours is 10.5 hours into how many minutes? 60 minutes. So it is 105 into 6. These many minutes have elapsed in the clock. So the clock is showing this number of minutes have happened. So if the clock shows 63 minutes, actual time passing is 60. So if the clock is showing 105 into 6 minutes, actual time would be how many minutes passed. So it is 105 into 6 into 60 by 63. So you can take 7 9s are 7 1s are 7, 7 5s are 35, 3 2s are 3 3s are, and 3 goes 20. So this is 30 into 20, which is 600 minutes. 600 minutes means 10 hours. 10 hours from when? 10 hours from 12 p.m. which means the correct answer is 10 p.m. The correct answer is 10 p.m. So this is how you deal with fast and slow moving clocks. Okay, so always look at overall what is the clock passing. So if it is slow, if I say the clock is running 2 minutes slow in every 60 minutes, which means it shows 58 minutes when the actual time is 60. Then you will write the second part depending upon what the question is. So you should write this entire time elapsed, 63 or 58, depending upon whether the clock is fast or slow. Please keep that in mind. Okay, next question. This is a very simple one. I'll give you 45 seconds once again. Please give me the answer to this. Rishabh, you want me to repeat? Okay, I will repeat after this question once again. Okay, so that's your 45 seconds. Lot of correct answers. The correct answer happens to be C. What is a reflex angle? A reflex angle is an angle which is greater than 180 degrees. So when any angle like this is formed, this, if it is theta, a reflex angle is the larger angle. See, when you have two lines, the angle can be measured either in this direction or it can be measured in this direction. This larger angle is called as a reflex angle. Okay, whereas this is a smaller angle, less than 180 degrees. So one angle will be more than 180, the other will be less than 180. The greater than 180 is called as a reflex angle. So at 10:05, what happens? This is my clock. So if I draw in red color my minutes hand, rather hours hand. So this is my 12, this is my 3, 2 and 1. At 10:05, so basically at 10 o'clock, this would be my hours hand. Okay, so this is 11 and 10. So at exactly 10 o'clock, my hours hand is here and my minutes hand is here. Okay, now what is happening? For 5 minutes, this is exactly 10 o'clock. For 5 minutes, my minutes hand is moving. It will keep moving. It will come to this point. So this is my minutes hand. And for 5 minutes, my hours hand will also move. But how much will it move? It will move very less because it's only 5 minutes. So effectively, in this original angle of 60 degrees, what are you adding? You are adding extra 30 degrees, right? You are adding because it is opening up, but you will also have to subtract this. You will also have to subtract it because that is closing. So this side is opening up, this side is closing. So you need to take care of both. So 60 plus 30 is 90. But 90 is not your answer. 90 minus whatever this angle, negative angle is, or that whatever that closing part is. That will be your smaller measurement of angle. So 360 minus that will be your correct answer. So how much is that? 90 minus what is this angle? This is the angle moved by the hours hand in 5 minutes. That is 2.5 degrees because half a degree per minute is the speed. So in 5 minutes it will move 2.5 degrees. So minus 2.5. This is 87.5 degrees. This is your angle made by the minutes hand and hours hand at 10:05. But this is not the answer. They are asking you the reflex angle, which means you are looking at this entire angle. This is 360 minus 87.5, which happens to be 272.5. Because reflex angle, they are talking about the larger part. So you get the smaller part, you'll get the larger part from there. That's basically how you calculate. Okay, I think last question. Rishabh, do you want me to go back or is it okay? Let me know, Rishabh, if you want me to explain the previous question. Till then, let's move on. Question number 5. This again a very quick question. 45 seconds is the time. You can get the answer in 45 seconds. The time starts now. Very good, Chinta and Alka. Correct answers. So that's your 45 seconds. The correct answer is option D. So what happens in 1 minute, the relative speed between them, 1 minute the relative speed is 11 by 2 degrees, 5.5 degrees. So in 45 minutes, how much extra is the relative? So basically it is like distance between them for 1 minute is 11.5 degrees. In 45 minutes, what will happen? The distance will just increase by that much. So 11 by 2 into 45. So for 45 into 11 is 495 by 2. So this is 200, 2 2s are 2 5s are 2, sorry, 2 4s are 8, 2 7s are 14. So 247.5. That is 247.5 degrees, option D. Because we know that in 1 minute the gap between them will become 11.5 degrees because the speed difference is 6 minus half, 5.5. So in 1 minute, if the difference between them or the distance between them becomes 11.5, in 45 minutes it will become 11 by 2 into 45, and that is your straightforward answer. Okay, going back to this one question which I think was asked, I believe. Was this? No, I think this is the question. Okay, so what is happening here is 63 minutes when it's shown, 63 minutes in my clock is 60 minutes actual time. Now the clock shows 10:30 p.m. which means how many minutes have passed? Remember, 63 minutes passing in my fast clock is actual time passing 60 minutes. So 10:30 p.m. means we are talking about 105 into 6 minutes. In my clock, this is equivalent to how many minutes in the correct clock, cross multiplication. You will get this as 600 minutes, which means that is 10 hours. It's basically a cross multiplication problem. That's all, Rishabh. Is that clear? So let's move on. Okay, once again, this is a 1 minute question. Not a difficult one, but this is the first time you're dealing with coinciding in today's class. I'll explain this, but first try it on your own. Time starts now. Okay, Rishabh is asking why 105. Rishabh, 10.5 hours, 10.5 hours, 10:30. 10:30 is how many minutes? Please calculate. 10.5 means 10.5 into 60. So 105 into 6. Okay, so that's your 60 seconds. The correct answer happens to be option D. Very good, Krishna Deshmukh, Mansi, Dharmi Thakkar and Bhavana. Correct answers. Now, let's take a look at what is happening. 8 o'clock, exactly at 8, what happens? This is your, if I change the color again, this is 8. So, my minute, hours hand is here and my minutes hand is here. Okay, what is the angle between them? What is the angle? 8 numbers, each number is 30 degrees, so 8 threes are 240 degrees. Think of it again as a police and thief problem. This is your police, this is your thief. The police should catch the thief. Coinciding means what? They are meeting each other. So coinciding is meeting. So the police is running from behind and coming to catch the thief. The distance between them is 240 degrees. The relative speed is 5.5 degrees. The relative speed is 5.5 degrees per minute. What is the time taken for them to meet? This is simple time and distance problem. Your time is distance between them 240 degrees by relative speed between them, which is 11.5. So 11 by 2, so into 2. So the time taken for them from 8 o'clock is 480 by 11, which is 11 fours are 44, 40 again, 11 threes are 33. In fact, there is only one question or one option with 43 in it. In fact, you can divide this, you will be getting this as 7 by 11 properly. So after 43 minutes, they will approximately 43 7 by 11 minutes, they will coincide, which means they will meet. The meet means the both hands are coinciding. That is, and it is not more than 1 hour. So from 8 o'clock, less than 1 hour, that is 43 minutes. So that is your correct answer. Clear? Let's move on. Okay, once again, not a very difficult question. Do this in 45 seconds. Your time starts now. Very straightforward question. Which question, Vicky? And what unitary method are you talking about? Which question are you talking about? Okay, so 45 seconds are done. A clock is started at noon by 40 minutes past 4. So 4:40. So totally how many minutes? This is 6 fours are, because 60 minutes per hour. So this is 240 minutes. This is 40 minutes. So total time elapsed is 280 minutes. Okay. The hour's hand has turned through. Now speed of the hour's hand is half a degree per minute. So for 280 minutes, it will turn 140 degrees straight forward. Nothing to do in this. Okay. Okay, Vicky, the time gain question. Okay guys, many of you are having a problem in the time gain. Let me explain this once again. This time I'll use a different example. Let us say a clock loses 5 minutes per hour, which means if I set it correctly at 12, if this is correct, if I am setting it correctly at 12, it will show 12:55 when actual time is 1 o'clock. That is the meaning. It will show 12:55 when the actual time is 1, because it is losing 5 minutes per hour, per correct time of 1 hour. Now, if the question says, look, the clock is showing, let's say 3:40, what is the correct time? Now, what you need to understand is for 55 minutes elapsed, 55 minutes elapsed in the clock, that is, this is in the clock, this is actual. So if 55 minutes have happened in the clock, outside correct world, the time is 60 minutes elapsed. Now in the clock it is 3:40, 3:40 in the clock, that's the question. So from 12 o'clock to 3:40, how many minutes is it? 3 hours 40 minutes, which means 180 plus 40, 220 minutes. So the clock has elapsed 220 minutes. So actually how many minutes would have happened? That is the way in which you write the question. So 220 into 60 by 55, 11 5s are 11 20s are 5 goes 4 times. So this is 240 minutes. So the correct world outside the clock, the correct time would have been 240 minutes. So how many hours is it? 240 by 60, which is 4. Okay, so this is 180 plus 220. Yes, this is 4 hours. 4 hours means it would be showing 4 p.m. It would be showing 4 p.m. This is how you calculate. Is that clear, Vicky? Okay. Let's move on. I hope that also answers your question, Mayank. I think you are also asking for the same question. Anyway, let's move on. Okay, this is a question which combines two things, fast and slow together. Okay, Vicky is asking a question. Can't I say per hour it's losing 5 minutes, so 3 it would be lost 315 by the unitary method? Isn't it simpler? No, it isn't like that. See, because you are saying if you know 3 hours outside, then 15 minutes slow. So if I say in this question, if the correct clock is showing let's say 3 p.m. then this is easy for you to calculate, because the correct is 3 p.m. means 3 hours, every hour 5, so for 3 hours 15 minutes loss. 15 minutes loss means 15 minutes less than 3, so this will be showing 245. But here what I gave is 340 was given to you in the clock, not outside. Then your calculation will not be correct, Vicky. You understood? So you should understand which time am I giving. If I say 3 p.m. in the actual clock, then what you're doing is correct. But if I say 3 p.m. is shown, here, then you cannot say for 1 hour it is 5 minutes. So 3 hours, how many minutes? There is a problem here. Why? This 1 hour is actual, whereas this 3 hours is clock. So you are comparing your actual with clock directly. That is not correct. Your actual and this should be 3 hours now. Then you should be asking here. So that is how you need to do. So 1 hour is 5 minutes you will be losing. So 5 minutes means you'll actually get 55 minutes shown. So 3 hours elapsed. So remember, unitary method, the meaning should be same. So when I say 1 hour, 5 minutes, you cannot write 3 hours here. Why can't you write 3 hours? Because what is the meaning of this 5 minutes? This is 5 minutes lost. Is this lost? Even if I say 3 hours is in the clock, is the 3 hours, the meaning, is it equal to 3 hours lost? It is not. So when you wrote 1 hour is equal to 5 minutes lost, you should also write the lost time here. But you don't know what is the lost time. You are supposed to find that out. Clear? So you have to be very careful in this unitary method. This is one of the traps students fall into. Anyway, try this. This is a question where you're dealing with both a clock being fast and the other clock being slow. Try it out. Okay guys, so that's your 1 minute. The correct answer happens to be option B. Let's take a look at why is it option B. So if you look at this question, one clock is gaining 5 minutes, the other clock is losing 1 minute. So let's take an example. Clock A, clock B, and this is correct. So let us say at 12 o'clock, just as an example, 12 a.m., both are showing exactly 12, right? They are both showing exactly 12 and it is a.m. Remember, when they say a.m., which means a.m. should be, so there is an a.m. and p.m. So it is not just an analog clock. It is an analog clock where you can differentiate between morning and evening. There is a difference between, it's a very important part. I'll tell you why it is important. Okay. Now, at 1 o'clock, what will happen? 1 a.m. Now, this is the fast. Let's say this is a slow. Now, this fast clock will show me 1:05 and the slow clock will show me 12:59. Correct? The slow clock will show me 12:59. So what is the difference between these two clocks? The difference between these two clocks is 6 minutes. Because one is fast, one is slow. So the net effect is 5 plus 1, which is 6 minutes. Now think of it like two people running. They are both starting from here. One person is running this side, one person is running this side. After 1 hour, this person came only till here. He is here. This person came only till here. This is here. So this is your 5 minutes. This is your 1 minute. So the total distance between them is 6 minutes. Now if I ask you, when will they meet? When will they meet again? Which means, wherever they meet. So one person is going this way, one person is going this way. Wherever they meet, this total between them, the total distance covered between them should be your complete circle. The total distance covered between them should be one full circle, only then they will meet. Correct? Now, that is the basic logic you're looking at. So 6 minutes will be the distance between them for every 1 hour. For every 1 hour, the distance between them will become 6 minutes. Starting point, they are all at the same point. So the initial distance was 0. Every 1 hour, the distance between them becomes 6 minutes. Right? Now, if they are meeting for the first time, which means both of them are showing the same time, they are both at the same point, showing the same time, it means the total distance between them should be equal to the circle. That is when you are dealing with AM and PM not being there. If it is only one clock, right? If it is only one clock, you are starting and they are running into a circle. Now the problem is there is an AM and a PM, which means think of this clock not as having 12 hours, but it is a bigger circle having 24 hours. Because you need to make sure that AM and PM also becomes, yes Vicky, that is correct, 5 minus of minus 1 is 6. That is what I wrote now, 6. So what you are doing here is, it is not a clock of 12 hours anymore, because see, in a normal analog clock, if I just show this, you will say the time is 1, but you don't know whether it's AM or PM. If I ask you when will it be 1 again, you will say it will become 1 again after 12 hours, correct? But if I say that there is a AM and PM written here, now in this clock if I ask, it is 1 o'clock right now, when will it show 1 AM again? You will not say after 12 hours, because after 12 hours it will show 1 PM. So you will say it will show 1 AM after 24 hours. It will show after 24 hours. So that is the logic that we're going to use. So every 1 hour, the distance between them will increase by 6 minutes. After 24 hours, because we want the full circle to be covered by them. Here for us the circle is not 12 hours, it is 24 hours. So in 24 hours, what will be the distance between them, or when will the, basically they are saying that after how many days. So this total distance run by them will be how much. So what is this point where they are going to meet? So 6 minutes every 1 hour is the distance. In 24 hours, what will be the total thing? So you're going to look at 24 into 6 by 1, but this is 6 minutes, so 6 by 60. Is it something wrong? Wait. Oh, my bad. I think I wrote it in the reverse order. Yeah, I wrote it reverse. My bad. Yes. So this should be 24 hours will take How many? So you want the distance covered between them to become the full circle. The full circle is 24 hours. So they will cover a distance of 6 minutes in 1 hour time. You want the total distance to be covered as 24 hours. How much time will it take for them to cover the full 24 hours? That is a question. Because the distance between them will keep increasing. At a certain point, they will both come. One will come from this direction, one will come from this direction, and they will both meet at the same point. And the total distance covered by them will be one full circle. Here in our question here, because there is an AM and PM, full circle means 24 hours. So 6 minutes distance covered in 1 hour, 24 hours distance covered in how many hours? So you'll get 24 into 1 by 6. But remember, this is 6 minutes, so into 60. Because 6 by 60, that 60 will go up, right? Because you're converting everything into hours. So this is 6 goes 10 times, so this is 240 hours. 240 hours means 10 days, because 1 day is 24 hours. 240 hours is 10 days. That is your answer. Clear? So when you're talking about two clocks, one being fast and the other being slow, the net distance between them will always be 6 minutes in this kind of a question. The faster one minus the slower one. So that basically you are adding them up. That will be the distance covered between them in 1 hour. And when you want them to show the same time, you have to be first careful. Is there an AM PM mentioned again? If there is an AM and PM mentioned, then the full circle for you, or the full length of the circular track for you, is 24 hours. If there is no AM and PM, then the length of the circular track is only 12 hours. In that case, instead of this 24, you will write 12. Clear? Let's move on. Okay. This is a straightforward question. 30 seconds should be your answer. Very, very quick. I mean, we already saw this question. Very, very straightforward. Guys, what is the answer? Remember, the actual plus mirror should be 12 hours. So the actual is 9:10. So mirror should be how much? So mirror should be 12 minus 9:10. So this should be 2 hours 50 minutes. Option A. Clear? So the correct answer is option A. Right, so Krishna is asking both hands move in same direction. Yes, both of them are moving in same direction. That is also fine. You can do this question I wrote this in opposite direction so that it becomes easy for you to understand. But if both of them are moving the same direction, then also it doesn't really matter. This basically is covering, let's say 5 minutes per hour. Okay. And the other one is moving slower. So basically what is happening? This is 5 minutes. So this covered one full circle and came here. So this is this distance. Okay, let me draw this better. Okay, so the minutes hand I will draw inside. Guys, are you there? Are you able to hear me? Can you just look at the chat? I'm not able to see the chat. Can you scroll down? Yeah, right. Okay, so answering the question of Krishna as well as Vicky. So they were asking, why did I take opposite direction? Because in this question when I was explaining, I took 5 minutes here and I took 1 minute here and I added them. But your question is relevant. You actually asked me, they are both moving in the same direction. If that is the case, why am I taking it in the opposite direction? Well, same direction also, this is how you need to understand. I will take hours hand, or rather the faster guy inside, I'm drawing it, and the line that I draw outside is the slower guy. So the faster guy, imagine, will finish one full circle and go extra. So this is the position. This is 5 minutes. Let's look at this slower guy. What is the slower guy doing? Slower guy will start, he will not finish the circle in 1 hour. In 1 hour, where is he? In 1 hour, he'll be here. 1 minute. So, even if you take it at the same direction, you will actually get the distance between them to be 6. Clear? Right, guys? Krishna as well as Vicky, did you understand this? Okay. Let's move on to the next question. So this is straightforward. I think this is done. 9, 10, 250, this is done. Okay. Try this. Try this question. 60 seconds. Karan, I did not understand your question. Can you please explain what do you mean? Yeah, in the previous question, yeah, every hour, so first hour the difference is 6, second hour will be 12, third hour is 18. So every hour it will be multiples of 6, correct, in the previous question. Very good, Rishabh and Krishna, Vicky, correct answers. So what is happening at 11? So if you look at it, exactly at 11, so this is your 9, 10, 11 and 12. So at 11, this is how it is. So the angle is exactly 30 degrees. Okay, but if you notice, all of them are above 11. So starting itself is 11, but they are asking in between 11 and 12. So what happens actually is, this hand, if you notice, this hour's minutes hand will keep rotating, and somewhere it will come over here, and this small hand will go over here. So this will be somewhere over here, and this will be somewhere over here, and therefore this angle is going to be 30 degrees. So there will be the second 30-degree angle formed. In fact, every angle will form 2 times in 2 hours, in an hour. Once once will be like this, small hand and big hand. Then the other time will be, the small hand will come over here, the big hand will be here. So whatever this original angle was, this angle will be the same. So this is theta, it will again form theta like this. So within 60 minutes, every angle will be getting formed twice. So here we saw, starting itself is 30, there will be one more 30 formed after some time. How much time is it? So look at the question. When we are looking at this angle, originally if I draw it in red, okay, starting point, this angle was 30, which means the reflex angle here is how much? 330 degrees. 330 degrees. Now what is happening? This big angle is getting decreased, and ultimately this big angle is becoming 30 degrees. So how much has decreased in that big angle? Right? Because that's what is happening. Your minutes hand is running fast, your hours hand is running slow, so this 330 gets decreased. So the 330 gets decreased and comes to 30 degrees. So it has lost totally 300 degrees. It has lost, the distance covered is 300 degrees. Now the relative speed is 11.5 degrees. Okay, 11 by 2. Not 11.5, 5.5. So 11 by 2. So 11 by 2 degrees in 1 minute. They should cover a net effect of 300 degrees. How many minutes will it take? So 300 into divided by 11 by 2, which is 600 by 11. So 11 5s are 55. Then we have 55 50. 11 4s are 44. So 6 by 11. So 54 6 by 11. That is option A. So you just measured, originally the big angle is 330. Now finally, so this big angle will completely reduce, and it is only this much is left. That is what is left. 30 degrees is left. So 300 degrees is lost. 300 degrees is lost means at what time will it happen? So 300 divided by the relative speed, which is 11.5. That is 11 by 2. Not 11.5, sorry, I keep saying 11.5. It is 5.5. 11 by 2. Clear? Okay, one last question for the day. So here's a question, very straightforward. Again, it's like 15 seconds. You should be able to give me the answer. 15-20 seconds. Last question, a very easy question to wrap up the session. We could not finish calendars today. We will definitely take up calendars in another session for you. I intended to take clocks as well as calendars, but I could not finish both. So we will take up calendars in another session. Right. So correct answer here is C. In 36 minutes, the minutes hand gains over the hours hand by. So the minutes hand is faster by 5.5. So that is 5.5. 11 by 2. So the minutes hand gets 11 by 2 every minute. So in 36 minutes, it will get 11 by 2 into 36, which is 11 into 18. 11 into 18 is 180 plus 18, 198. Option C. Done. So this is comprehensive, guys. This is enough as far as your clocks are concerned for MAHCET. If you revise whatever we did today properly, I am 100% sure that any clocks based question you will be able to crack in the exam, and crack it within 45 to 60 seconds max. Right? So this is an easy topic, but you saw the pitfalls, you saw the errors that you can make. Make sure that these errors are corrected. You will be having free marks coming your way. Right? Thank you, my friends. Thanks for visiting my session, participating over here. You have been a wonderful crowd. See you in the next one.